Today we're going to be talking about graphing secant and cosecant functions. By the end of this video, you should be able to graph secant and cosecant functions and be able to state the domain and range. So first, cosecant is the reciprocal of sine. So that means that all of the values that we used for sine, we are taking the reciprocal of. So let's write these down. When we graphed our sine functions, we had 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. So when we are looking at the reciprocal for cosecant, we have 1 over 0, which is undefined. 1 over 1 is still 1. 1 over 0 is undefined. 1 over negative 1 is negative 1. And 1 over 0 is undefined. So that doesn't give us the best idea of what our graph is going to look like. So let's go ahead and start plotting things and see what happens. We're going to label our axes the same way we have for all of the other trig functions. So let's plot what we have. So we are going to have asymptotes at 0, pi, and 2 pi. And then we have points at pi over 2, 1, and 3 pi over 2, negative 1. So the way that our curve is going to look is we are going to have these little U-shaped pieces of the graph. And if we continue this pattern, we're going to have asymptotes at every multiple of pi, and the little U-shapes are going to alternate positive and negative. So that's what our graph for cosecant is going to look like. When we write out our domain and range, that's going to be similar to the domain and range we wrote for tangent and cotangent functions. Our domain is going to be x such that x does not equal the asymptotes. The asymptotes are multiples of pi, so I'm going to write pi k, where k is an integer. Our range is going to be negative infinity to negative 1 and positive 1 to infinity. Let's take a look at the graph of secant now. Secant is 1 over cosine. So let's make our chart. For the graph of cosine, we had 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. So if we do the reciprocal of these, we have 1, undefined, negative 1, undefined, 1. So we're going to label our axes the same way. So we are going to have vertical asymptotes at pi over 2 and 3 pi over 2. Then we're going to have points at 0, 1, pi, -1, 2 pi, 1. So our graph for secant is going to be very similar to our graph for cosecant. We are again going to have these little U-shaped parts of the graph. If we continue this pattern, we are going to have some more vertical asymptotes, and the U-shaped pieces of the graph are going to alternate positive and negative. I'm going to go back to the secant graph for a minute and highlight the first period of this graph. So our first period for cosecant is this part of the graph, but the first period for secant is this. So the graph is divided up into a couple different pieces. The domain for this function is again going to be x such that x does not equal. You want to pick an asymptote. I'm going to pick the first one, which is pi over 2 plus, and you can see that the asymptotes are pi units apart. So I'm going to say plus pi k, where k is an integer. Our range is again going to be -infinity to -1 and +1 to infinity. So those are the two graphs that we're looking at today. Again, we are not going to use the word amplitude with secant and cosecant. Other than that, everything is the same as it has been for all of the other functions in terms of finding the period, the quarter period, the horizontal shift, and the vertical shift. So if you need to write that down as a reminder, we have y equals a secant of bx minus c plus d, or we could have cosecant here. It's the same for either function. A is our stretch. The period is going to be 2 pi over b, because if you go back to the graphs and look, it does take 2 pi units for the pattern to start to repeat itself, because we have a positive part of the function and a negative part of the function. The horizontal shift is c over b, and the vertical shift is d. So let's take a look at our first example. We have a of x equals 2 sine x plus pi over 4. Now I realize that this is a sine function and that's not what we're talking about today, but I need to show you something. So if we look here, our amplitude, we can say amplitude because this is a sine function, is 2. The period is going to be 2 pi because b is 1, so that means our quarter period is pi over 2. The horizontal shift is going to be negative pi over 4 divided by 1, so negative pi over 4. Our vertical shift is 0. So our starting point for the graph is negative pi over 4, 0. I'm going to label my axes. And I am starting at negative pi over 4, 0. Since this is a sine function, we're going to go 0, high, 0, low, 0. So I have an amplitude of 2. So there is my sine curve. You should remember that the domain for sine and cosine is all real numbers or negative infinity to infinity, because you can keep that pattern going on forever. The range for this function is going to be -2 to 2. Now, I want to compare this with our cosecant graph. So I have b of x equals 2 cosecant of x plus pi over 4. So it's the same information as the sine function, just the cosecant function. My stretch is 2. The period is still 2 pi, so the quarter period is pi over 2. The horizontal shift is negative pi over 4. The vertical shift is 0, so I start at negative pi over 4, 0. Same information. So I'm going to label my axes. Now, I'm starting right here. Since this is a cosecant function, originally my asymptotes were 0, pi, 2 pi, 3 pi, etc. Now, my asymptotes are going to be negative pi over 4, and then multiples of pi from that. And you could keep going if you needed to. Since this is cosecant, and my stretch is 2, I'm going to have a graph that looks like this. Now let me show you the part that is helpful. If I take this graph of the sine function and move it over, you can see that it fits exactly inside this graph of the cosecant function. So this is how I usually graph secant and cosecant graphs. I think in my head that I'm graphing either sine or cosine. I do the points for that graph. Any place that the sine function is 0, I'm going to have a vertical asymptote in the cosecant function. And then the u parts of the secant and cosecant graph are going to sit on top of the sine or cosine curve, depending on which function it is. So let's continue with our last couple examples. Here we're going to look at cosine and secant. We have cosine of 2x and secant of 2x. So here our amplitude is 1. The period is 2 pi divided by 2, which is pi. Our quarter period is going to be pi over 4. There is no horizontal or vertical shift. So we are still starting at 0, 0. We're just changing the period. Since this is a cosine function, we're going to think high 0, low 0, high. I'm going to go ahead and label my axes. So since my starting point is going to be 0, 0, and this is cosine, my amplitude is 1, so I'm going to start high. My quarter period is pi over 4, which means that at every line on this graph I should have a point. So then I go 0, low, 0, high. So this is my cosine curve. The domain for this is negative infinity to infinity. The range is negative 1 to positive 1. Now let's compare this with the graph of secant of 2x. The vertical stretch is still 1. Period is 2 pi divided by 2, which is pi. So the quarter period is pi over 4. My horizontal stretch and vertical stretch are both 0. So let's label the axes. Now, we are still starting at 0, 0. So I'm going to think in my head that this is going to be similar to a cosine graph. So I'm going to go ahead and put the 5 points that I put for my cosine graph. To change it to a graph of secant, anywhere that I had a point on the x-axis, I'm going to make a vertical asymptote. And then from the other points, I draw the little U-shaped parts of the graph. So that would be my graph for secant 2x. The domain for this function is x such that x does not equal, pick the first asymptote, which is pi over 4, plus, and then you want to look and see what is the distance between the asymptotes, or what is half of the period. So in this case, pi over 2 times k, where k is an integer. The range for this function is negative infinity to negative 1 and 1 to infinity. So that's how you can use the cosine graph to graph a secant function. You have one last example. E of x equals 3 cosecant of x minus pi plus 1. So let's write out all of our information. Our vertical stretch is 3. The period is 2 pi divided by b. b is 1 in this case, so our period is 2 pi. So the quarter period is pi over 2. The horizontal shift is going to be c over b, so pi over 1, or just pi, so we're shifting to the right. Then the vertical shift is 1, so we are shifting up. So our starting point is going to be pi 1. Since this is a cosecant function, cosecant is the reciprocal of sine. For sine graphs, we think 0 high, 0 low, 0. Let's label our axes. Since our vertical stretch is 3, I'm going to go ahead and change how I label the y-axis and make this 1, 2, 3, 4. So I'm going to think that I am graphing the sine function with these characteristics. I'm going to start at pi 1. My period is 2 pi. The quarter period is pi over 2, so I'm going to have a point every pi over 2. Since this is sine, I'm going to go 0 high, and our vertical stretch is 3, so I'm going to go up 3, 0 low, 0. Okay. Any time that I had a point on, it's not the x-axis, but the quote 0 part of this pattern, I'm going to draw a vertical asymptote. And And then I'm going to sketch the U-shaped parts of the graph. And that's it. My domain is going to be x such that x does not equal, start with one of the asymptotes, it's pi, plus the distance between the asymptotes, which is pi k. Now, since my asymptote was at pi and I'm adding pi, this is the same as if I had written x such that x does not equal pi k. Either one is correct, but the second one is a little bit simpler. Then our range is negative infinity to negative 2, because that is the highest point on the low curve, and 4, because that's the lowest point on the high curve, to infinity. And that's it.